Okay, so here let's take a look at an additional example. So yeah, so here it says the volume charge density of a solid non-conducting sphere of radius capital R varies with radial distance R. OK， 所以这个不是一个均匀的电荷分布。Oh, and actually this density rho is proportional to the small r. So it first asks what is the sphere's total charge? OK， 所以第一步就是先算这个球的总电荷是多少 ？OK， 就是它给你密度，给你那个形状 OK。OK， so actually the Q will be something like integrating the volume charge density over the volume. Okay, so yeah, so we have a triple integral because this is like a sphere. And actually, we would like to use the spherical coordinate， 就是一个叫做球坐标的东西。那球坐标的话，就是说，对，OK， so it will be like, yeah, integrating this expression. Let's call this thing rho s. Okay, so we can write less thing because 35.4 times 10 to the 11 negative 12 is it's not easy to write. Okay, so let's call this number rho s. Okay, so here we have rho equals rho s times small r over capital R. Okay, so here we integrate this thing as rho s times r over capital R. And what is dv? Okay, dv in spherical coordinate will be like r squared sine of theta, and then times dr d theta d phi. Okay, what is this stuff? Okay, so and actually for dr will be integrate from 0 to capital R, and then d theta will be from 0 to pi, and then d phi will be from 0 to 2 pi. Okay, so what does it mean? So let me try to find spherical coordinate. Okay, so okay. Okay, so actually this is the spherical coordinate. Of course, you might be more familiar with the Cartesian coordinate， 就是这个直角坐标系嘛，就是 x y z 这样的。Okay, but yeah, actually we have something called cylindrical coordinate or spherical coordinate. Okay, for spherical coordinate, we have the variable of r, theta, and phi. And actually, r means the distance from that point to the origin， 就是原点到那一点的距离，就是 r。所以 r 的话就会等于 x square plus y square plus z square, and then take the square root of the whole term。就是看一下没有，就是对，就是 r 会等于 x square 加 y square 加 z square, and then take the square root, and then it also has the theta and phi. What is theta and phi? So theta is actually we connect this point to the origin, and then the angle between the z-axis and this line will be theta. Okay, so this is theta. So actually this line, okay, so we'll have 0 degree when when this point is on the z-axis, on the positive z-axis, okay, then theta will be 0 degree. So, and then it will become larger and larger until this point is going to the negative z-axis. Then this theta will be 180 degree, which is pi in radian. OK， 所以这个 theta 的话只会有0度到180度之间，它不会超出这个范围。就是在后面的话，它也是 theta 是一个正数的，就是这个 theta 就是 z 轴跟这一点跟原点的连线所夹的角叫做 theta。那 phi 是什么 ？Phi is actually you try to project this point on the xy plane, on the xy plane, and then you have the angle theta is actually from x-axis to this line. Okay, phi is the angle between this positive x-axis and the point you project to the xy plane and then connect to the origin point. Okay, so in that case, this phi can have value from 0 degree all the way up to 360 degree. 所以那个就像是一个极坐标嘛，极坐标的话就是 xy 面上面其实是一个极坐标，就是有一个 r， 它一定是非负的，就是从0开始往一个正数方向。那 theta 的话只会是0到360度，就是2派之间。那 theta 就是另外的，就是第三个维度，就是跟 z 轴的夹角，所以它是0到180度之间。OK， 就是这样。所以如果我们要积分一个球，一个完整的球体的话，它dr 的话是从0到 r 去做积分啊 ，theta 的话是从0到派去做积分 ，phi 的话是从0到2派去做积分。那为什么会有这个东西的话，就是相对比较复杂一些，这个叫做 Jacobian 啊 ，Jacobian 就是有一些叫做变数变换的东西，就是不知道这里有没有说。对，因为这个就是 r 会等于这个，然后 theta 会等于这个，然后 phi 的话会等于这个啊，就是用一些三角函数可以推导出来的，其实不会很复杂啦。然后刚才提到的一个叫做 Jacobian 啊 ，Jacobian 这里有没有啊 ？Jacobian 就是这个东西了，就是这个东西。那它算出来的话就会讲这样了，就会就是 r 平方 sin theta dr d theta d phi。我读书的时候就是把它背起来了啊，但是考试也没有考那么难的，所以就是大家明白一下就好了。OK， 所以我们算这个 triple integral， 这个 triple integral 算起来很简单的啊，算起来很简单的。Okay, so actually, to calculate this triple integral is not that difficult. Okay, although it's a triple integral, but all the variables can be separate. So first of all, this is a constant. This is a constant. So we can just put it out. So rho s over r, and then we have actually this is r. This is r squared. And then dr, so we only have something like dr r cubed from 0 to capital R, okay? And then we have this part sine of theta d theta, so we have a sine of theta d theta from 0 to pi, and then finally d phi, we don't have anything. You can consider it's like 1, okay? Or you can just ignore it and then integrate from 0 to 2 pi. Okay, so calculating these 3 in the free draw integral is easy. So it is like rho s over capital R, and then this is nothing but R to the 4th power over 4. And then this is the antiderivative is a negative cosine of theta, and then evaluate from 0 to pi, which will be 2, okay, because it is like negative cosine of theta, and then evaluate from 0 to pi. Okay, so this is 1, this is negative 1, and then with a negative sign, so it becomes 2. And then this one, integrating 1 will be 5, and then evaluate from 0 to 2 pi, which is 2 pi. Okay, so yeah, calculating this thing is really easy. Okay, so finally we can have the final answer to be, yeah, we can simply cancel this 2, 2, and 4, and then this r and r to the 4th power down to r cube. Okay, so finally the answer will be rho s or maybe pi rho s r cube, and then we can plug in the values. 3.14 times rho s is 3.5 times 10 to negative 12, and then times r cube. R cube is this one, 5.6 centimeter, which is 0.056 meter quantity to the cube. Okay, so it is actually 1.95 femtocoulomb. Okay. Okay, so this is for part A, and then for part B, it asks what is the field magnitude E at r equals 0. Okay, so this is very easy. You should be able to know that without any computation. So it is nothing but E equals 0, because yeah, if you just assume a Gaussian surface with radius to be 0, then it encloses nothing. Okay, so in that case, if you define a Gaussian surface with r equals 0 at the center of this sphere, and then we will have a Q enclosed to be 0. So in that case, E will also be 0. Okay, so this is easy. And then for the third part, okay, it asks you what is the E field at r equals to capital R over 3. Okay, so in such a way, we need to calculate the Q enclosed in this region. So we need to calculate the charge, the Q enclosed again. Yeah, so actually it is like this integral, but the lower and upper limit for the r will be nothing but 0 to r over 3 only. 0 to r over 3 only. So let's skip this part, and then we can actually write it as rho s over r, and then integrating r cube, r prime cube, dr prime from 0 to let's say small r to be this value. Okay, and then integrating sine of theta d theta from 0 to pi, and then integrating d phi from 0 to 2 pi. Okay, so yeah, so actually this is rho s over capital R, and then this is r to the 4th power over 4. Okay, and then this is still 2, and then this is still 2 pi. Okay, so the only difference is this one. So we get an expression of pi times rho s times r to the 4th power over capital R. Okay, so this is the Q enclosed if we have an R is smaller than or equal to capital R. And then here we can try to apply the Gauss law, which is integrating E dot dA and then times epsilon naught equals Q enclosed. And then on the left side it is still epsilon naught times E times 4 pi R square, and then Q enclosed is here pi times rho s times R to the 4th power over capital R. So in this case, we can do some cancellation. This r square partly cancel with this r to the 4th power down to r square, and then pi and pi cancel. Okay, so here we can get the expression of E to be, here we have a 4, let me see, 4 epsilon naught capital R in the denominator, and then we have rho s times R square in the numerator. Okay, so this is the expression of E when R is smaller than capital R, so or smaller than or equal to capital R. So in this case, we would like to find E when R is equal to capital R over 3. So in this case, E when R is equal to capital R over 3, which means that we try to substitute this thing into rho s, substitute this R to be capital R over 3, and then quantity square, and then we have 4 epsilon naught capital R. Then we will have rho s and then times R over, okay, here we have 3 squared times 4, which is 36 epsilon naught. Okay, this R is partly cancelled with this R squared, so we only have an R here. Okay, so finally we can plug in the values. This is 35.4 times 10 to negative 12, and then times capital R is 0.056 all over 36 times 8.85 times 10 to negative 12. Okay, so this number is nothing but 6.22 times 10 to negative 3 Newton per Coulomb. Okay, so this is the E at this position. And actually, for the 4th question, we would like to find R. We would like to find E when small r is equal to capital R. So actually, we can just make use of this expression. When we can just simply substitute R to be capital R, then it will be the answer. But actually, we need to graph E versus R. So we would like to also obtain the expression when R is larger than capital R. So yeah, so here, where we would like to apply the Gauss law. So epsilon naught times integration of E dot dA equals Q enclosed, which is the large Q where we obtain for the question A. Okay, so in this case, for the left side, it is still epsilon naught E times 4 pi R square, and then on the right side is this expression pi rho s R cube. Okay, in question A, pi rho s R cube. Pi rho s R cube. Okay. So here we can actually cancel this pi and this pi, and we have E equals rho s and then times R cube over 4 epsilon naught small r square. Okay, this is the expression when R is larger than or equal to capital R. Okay, so in such a way, when we would like to find when R is equal to capital R, so E of small r equal to capital R, which is rho s R cube, capital R cube over 4 epsilon naught over capital R cube. Okay, we just change small r to capital R, and then we can do some cancellation. So finally, we get a rho s over 4 epsilon naught. Okay, so this, yeah, so and then we can just substitute the numbers. Okay, rho s is 35.4 times 10 to negative 12 over 4 times 8.85 times 10 to negative 12. Okay, so this is nothing but sorry, we still have a R here. Okay, so we still need to multiply it by 0.056. Okay, here. Okay, so the answer will be 5.60 times 10 to negative 2 Newton per Coulomb. Okay, so this is the answer to question D. Okay, question D. Okay, so finally, we would be able to graph E versus R. Okay, so it will be something like this. Okay, for the x-axis it is R, for the y-axis it is E with the n over c as the SI unit, and then yeah, it is piecewisely defined with the region smaller than capital R and larger than capital R. For this part, it has the expression E is proportional to R squared, so which is like so actually it is like E equals rho s times R squared over 4 epsilon naught R, where when R is smaller than or equal to capital R, which we have obtained this expression in part C, and then in part D we get the expression when R is larger than capital R as rho s times R capital R cubed over 4 epsilon naught small r squared. Okay, so actually for this part, this E is proportional to R squared, and for the right side, yeah, this is proportional to or inversely proportional to R squared. Okay, for this part. Okay, and actually this point is 5.6 times 10 to negative 2. Okay, where we obtain it here. This is the peak. This is the peak value. Okay, so I think that's all for this chapter.